Unit 13 is writing and graphing exponential functions. And this shouldn't be too bad because we've already talked about geometric sequences, which were really just exponential functions, and we've already done some graphing these when we did our transformations of functions, when we move things up, down, left, right. So it kind of combines those two things together. But what an exponential function is, it's going to be an equation that starts with y equals, or it could say f of x equals a number times something to the x power. So exponential functions have x in the exponent. They also have a common multiplier. So we saw in our sequences something like this, where it's like the first number, a sub 1 was 3. Let's say the next number was 9. The next number, you can tell the pattern, it's times 3, so this would be 27. It had a common ratio, or you're multiplying by a common number. That's what a common multiplier is. And then in this, we'll talk about what this looks like after we do a couple problems. So our job in this first section is simply to take a table and write an equation of the exponential function that's represented. And so if I were to graph these points, I have a point at 0, 1, 1 up 2, 2 up 4, 3 up 8. So what's happening here is the distance between these 2 points, the vertical distance is 1, then it doubles and it goes up 2, and then from 4 to 8, it doubles again, and that's a difference of 4. But what it's going to do is make this shape, where it's very gradual and then it shoots up really quick. That's going to be called exponential growth. You don't need to know all that in this section, but I just wanted you to feel for what we're trying to find. So when I make an equation, I want to pick a point. It would be easiest to pick this one, 0, 1, where 0 is my x, 1 is my y, and I'm going to plug that into the function. So my y is 1 equals my a, and I don't know that, and then times b. My b is my common multiplier. Let's put that here. I'm going to put common ratio since that's what we've been using. Common ratio. Well, what are y's doing? 1 times what makes 2? Times 2. 2 times 2 makes 4. 4 times 2 makes 8. So we're going to say it's times 2 to the x power. Well, I'm going to put in 0. You have to remember that exponents come before multiplication. So I'm doing 2 to the 0 power. Anything to the 0 power is 1. Anything is 1. So I really have 1a, or a, equaling 1. What I'm going to tell you is you don't even have to do this. You need to know that a is really just the y-intercept. It was like the starting value or the initial value when we did our sequences. It was 3 times what to how many power, right? So really the equation for this is just y equals the y-intercept, which is when x is 0, so that's 1, times b is what is our common ratio, 2 to the x power. And you wouldn't even need that 1 there. You could just do y equals 2 to the x. And actually, this is the parent function that's on my poster on my wall. So let's try to do 2 a little faster because it's really, really simple. We're just going to say y equals a, again, is my y-intercept when x is 0. So that's 0.1, or 1/10, times whatever is my common ratio. Remember, if it's hard to tell, you take one term divided by the one before it. So I'm going to take 0.05 divided by 0.1. And I get 0.5, which is a half. You could check it again. I could take 0.025 divided by 0.05, and I should get that same ratio. Same thing with 0.0125 divided by 0.025, same ratio. So it's half of it. So you could put 0.5, you could put the fraction 1/2, and it's to the x power. And that's it.